Hello everyone and welcome to Who Created It and How. Today we're diving into one of the most magnificent engineering feats of the ancient world, the aqueducts. When you hear the word aqueduct, what comes to mind? Probably the Romans, right? Towering arched structures stretching for miles, carrying life-giving water to bustling cities. And you're not wrong. The Romans were the undisputed masters of aqueduct construction. But were they the first to come up with the idea? Not by a long shot. Let's travel back in time, way before the rise of Rome. The concept of moving water from a source to a settlement is as old as civilization itself. Early societies in Mesopotamia, like the Assyrians, were already building sophisticated canal systems. Around the 7th century BC, King Sennacherib of Assyria constructed a massive 50-mile-long aqueduct to bring water to his capital, Nineveh. It was a remarkable achievement, complete with waterproof arches and tunnels. Even earlier, the Minoans on the island of Crete were using terracotta pipes to manage their water supply, and the Mycenaean Greeks had systems of their own. So, the basic idea of diverting water was well established long before Rome was even a small village on the Tiber River. But if others did it first, why do the Romans get all the credit? It comes down to three things: scale, sophistication, and sheer quantity. The Romans didn't just build one or two aqueducts. They built hundreds, all across their vast empire, from Britain to North Africa, from Spain to Syria. Their engineering was on a whole other level. While earlier aqueducts were often simple open channels, the Romans perfected the use of the arch, allowing them to build taller, longer, and more durable structures that could cross deep valleys and rugged terrain. Let's talk about how they actually did it. The process was a masterpiece of planning and precision. First, Roman engineers known as architecti had to find a reliable water source. This was usually a spring or a river high up in the hills, ensuring a clean and constant supply. The next and most crucial step was surveying the route. Using simple but effective tools like the chorobates, a long wooden plank with a water level, and the groma for sighting straight lines, they meticulously calculated the gradient. This was the secret sauce of Roman aqueducts. The channel had to have a gentle, continuous downward slope, but not too steep. Too shallow, and the water would stagnate. Too steep, and the flow would be too fast, eroding the channel. The ideal gradient was just a few feet of drop for every mile of distance. Imagine calculating that over dozens of miles of uneven ground with only basic tools. It's absolutely mind-blowing. Once the route was planned, the construction began. This was a massive undertaking, often involving thousands of workers, including legionary soldiers, slaves, and skilled craftsmen. Most of an aqueduct's length was actually underground. Tunnels were dug through hills and covered trenches were laid across flat land. This protected the water from contamination and kept it cool. The iconic, beautiful arched bridges we see today were only used when necessary, to cross valleys or low-lying areas. These were constructed using stone, brick, and a revolutionary Roman invention: waterproof concrete made with volcanic ash called pozzolana. This material was incredibly strong and durable, which is why so many of these structures are still standing 2,000 years later. Inside the channel, the water flowed through a conduit called the spicus. This was typically lined with a special waterproof mortar called opus signinum, made of crushed terracotta mixed with lime. This prevented leaks and kept the water pure. Along the route, they built maintenance shafts for access and settling tanks to remove sediment. The whole system was designed not just to be built, but to be maintained for centuries. So where did all this water go? When an aqueduct reached a city, the water was channeled into a large distribution tank called a castellum aquae. From there, a network of lead pipes. And yes, they used lead, which we now know has health risks, though the constant flow of hard water likely created a mineral buildup that limited lead exposure, would carry the water to various destinations. The top priorities were public facilities. Grand public baths, which were central to Roman social life, consumed enormous amounts of water. Public fountains, known as lacus, provided free drinking water for the general population. Wealthy citizens, the domus, could pay a fee to have a private line connected directly to their homes, a true status symbol. Any excess water was used to flush the city's sewer system, like the famous Cloaca Maxima in Rome, improving public sanitation. The impact was transformative. Aqueducts allowed cities to grow far beyond the limits of their local water sources. Rome itself was eventually supplied by 11 major aqueducts, bringing in an estimated 1 million cubic meters of water per day. That's enough to fill 400 Olympic-sized swimming pools. This abundance of water supported a huge population, powered industries like milling and mining, and enabled a level of public hygiene that wouldn't be seen again in Europe until the modern era. They were more than just infrastructure. They were a symbol of Roman power, wealth, and technological prowess, a visible statement that Rome could tame nature itself to serve its citizens. After the fall of the Western Roman Empire, the science of aqueduct building was largely lost in Europe for centuries. Many of the Roman structures fell into disrepair. It wasn't until the Renaissance that engineers began to rediscover and study these ancient marvels, paving the way for the modern water systems we rely on today. So who built the aqueducts? The short answer is the Romans. But the long answer is a story of human ingenuity that spans multiple civilizations. The Assyrians and Greeks laid the groundwork, but it was the Romans who took the concept and perfected it on an imperial scale, leaving behind a legacy of engineering genius that continues to inspire awe. They didn't just move water, they built the foundations of a civilization. Next time you see a picture of the Pont du Gard in France or the Aqueduct of Segovia in Spain, remember the incredible skill, planning, and hard labor that went into it. These aren't just ruins. They are a testament to what humanity can achieve. That's all for today on Who Created It and How. I hope you enjoyed this deep dive into the world of ancient engineering. If you did, please give this video a thumbs up, and don't forget to subscribe and hit that notification bell so you won't miss our next adventure into the history of creation. Thanks for watching and see you next time.